Hello viewers, my name is Ajiboye Oladapo and I welcome you to the Global Tutor YouTube class. Today we want to consider the subject mathematics and I want to look at the topic trig ratios. Now let's start the topic like this. In trigonometry, we have 6 trig ratios: sine, cosine, tangent, cosecant, secant, and cotangent. This one is abbreviated as sine. This one abbreviated as cos. This one abbreviated as tan. This one abbreviated as d. This one abbreviated as sec. And this one abbreviated as cos. But for this level, we're going to be considering sine, cosine, and tangent. And in the class today, what we want to do is look at the relationship between sine and cosine. Now, you need to know that these trig ratios 1, 2, 3, 4, 5, 6 work with a right angle triangle. Now, we have to define what is a right angle triangle. A right angle triangle is a triangle whose one angle is 90 degrees. Now, one angle here is 90 degrees. That makes this triangle A, B, and C to be a right angle triangle. Now, if this is a right angle triangle A, B, C, and we are considering this angle as theta, we can label the sides of the triangle as the side facing this theta as opposite, the longest side as hypotenuse, then this other side would be adjacent. I'll come again. A right angle triangle is a triangle whose one angle is 90 degrees. So let's assume this triangle ABC is 90 degrees at C. Then we consider this angle as theta. Then the side facing theta will be opposite. The longest side will be hypotenuse and the other side will be adjacent. Now, we need to know the concept called SOHCAHTOA theorem. Now, what is SOHCAHTOA theorem? The first one, sine. O, opposite, over H, hypotenuse. K, C, cos, equals A, adjacent, over H, hypotenuse. Then the last one, T, tan, equals O, opposite, A, adjacent. I tried to show you the theorem. SOHCAHTOA. S here stands for sine theta, O for opposite, H for hypotenuse. K, C here stands for cos theta, A, adjacent, H, hypotenuse. Then TOA. T here stands for tan theta, O for opposite, and A for adjacent. So we're looking at sine, cosine, and tangent for the purpose of this class. And I said we would consider a right angle triangle. And a right angle triangle is a triangle whose one angle is 90 degrees. So if we consider triangle ABC and it is right angle at C, then if we consider this angle as theta, the side facing it to be opposite. The longest side will be the hypotenuse and the other side will be what? Adjacent. Now, I said earlier that we want to look at the relationship between sine and cosine. For us to do that, we are going to draw another diagram. This is a right angle triangle. It is right angle at this point. Let's say C. This is A. This is B. Now, the side facing angle A will be small a. The side facing angle B will be small b. The side facing angle C will be small c. If we go back to geometry, the sum of angles in a triangle equals 180 degrees. Now, we said this is 90 degrees. So 180 minus 90 will give us 90. So if we consider this angle as theta, it follows therefore that this angle will be what? 90 minus theta. I'll come again. We have a triangle ABC, right angled at C. Now, if we go back to geometry, the sum of angles in a triangle is 180 degrees. If this place is 90, then the other two angles, that will be 180 minus 90, which will give us 90. So if this place is theta, then this place will be what? 90 minus theta. Now, let's see the relationship between sine and cosine. So now, if we consider sine theta, remember we said sine is opposite over hypotenuse. If we consider cos theta, to this angle, this is opposite. This is hypotenuse, so this is adjacent. If we consider sine 90 minus theta, this is now the angle we are considering. So this becomes the opposite. So this is opposite. This remains the hypotenuse. So opposite over hypotenuse. Then cos 90 minus theta will be, this is opposite. So this will be adjacent. This remains hypotenuse. So by ratio, looking at it, let's call this equation 1, equation 2, equation 3, equation 4. By ratio, you will see that A over C is also A over C. The same thing. So we can conclude and say, therefore, cos theta is the same thing as sine 90 minus theta. Why is it so? A over C by ratio. Look at it. B over C. B over C. So by ratio, I can conclude that what? Sine theta is the same thing as cos 90 minus theta. Why is it so? B over C. Now, this is the relationship between sine theta and cos theta. The first one, cos theta is sine 90 minus theta. Then the second one, sine theta is cos 90 minus theta. These two equations, you must memorize them because you use them to solve questions. Remember, we have established sine theta is cos 90 minus theta, and also cos theta is sine 90 minus theta. Now, let's take example number 1. The question says, if sine 2 theta equals cos 30 degrees, find theta. Now, I always say something, that every problem has a solution. So this is a mathematical problem. Let's look for a mathematical solution to it. The question is sine 2 theta equals cos 30 degrees. Remember, sine theta is cos 90 minus theta. So now, see, everything here is everything here. So I can say sine 2 theta is cos 90 minus 2 theta. What have I done? I've substituted theta here for 2 theta in the above. So I can therefore write sine 2 theta as cos 90 minus 2 theta equals, what's the question? Cos 30 degrees. So look at it, cos. Look at this, cos. So I'm left with 90 minus 2 theta equals 30 degrees. So I can collect the like terms. This can move here. 90 minus 30 will be, this one will move here, 2 theta. 90 minus 30 will give me 60 equals, what do I have here? 2 theta. So I can divide by 2. I can divide by 2. So it means 2 will cancel 2. 2 here 1, 2 here 30. So your theta will be 30 degrees. That's example 1. I'll come again. The question says, if sine 2 theta equals cos 30 degrees, find theta. How do we solve that? Solution, sine 2 theta equals cos 30 degrees. What do we know? From above, we have established that sine theta is cos 90 minus theta. It follows therefore that everything you have here is the same as everything you have here. So theta can be replaced as what? 2 theta. So it means I can write sine 2 theta as cos 90 minus, what is this theta? This one, 2 theta here. So this sine 2 theta is the same thing as cos 90 minus 2 theta. So meaning I can say sine 2 theta, I replace it with what? This, cos 90 minus 2 theta equals cos 30 degrees. Cos, they can nullify. So we have 90 minus 2 theta equals 30. So what do we do? Collect like terms. 30 comes here, become minus. Minus 2 theta goes here, becomes plus. 90 minus 30, that gives us 60, equals 2 theta. Divide by 2. 2 here 1, 2 here 30. So your theta is 30 degrees. That's example 1. Let's try another question again. Number 2. The question says, if cos theta over 2 equals sine 60 degrees, find theta. The question is, if cos theta over 2 equals sine 60 degrees, find theta. What did we know? We go back here. Cos theta is sine 90 minus theta. What are we given in the question? Cos theta over 2 equals sine 60 degrees. This is theta. Everything here is theta. So I can write cos theta over 2 as sine 90 minus everything here, theta over 2. So anywhere I see cos theta over 2, I can replace it as sine 90 minus theta over 2. So I go back to the question. So I have sine 90 minus theta over 2 equals sine 60 degrees. Sine. So I'm left with 90 minus theta over 2 equals 60. From here now, what do I do? Let me multiply through by 2. So I'm going to have 2 into the bracket, 90 minus theta over 2 equals 60 degrees. 2 times 90, that gives me 180. 2 times theta over 2, that gives me theta. 2 times 60, that gives me 120. So what do I do? Collect the like terms. This come here, this goes here. So you have 180 minus 120. Then this one go here equals theta. So this 180 minus 120 will give us what? 60 equals what? Theta. Therefore, theta is 60 degrees. I'll go through the question again. The question says, if cos theta over 2 equals sine 60 degrees, find theta. We go back. We have established this. Cos theta is sine 90 minus theta. Now, in the question, we are not given theta. What we are given is what? Theta over 2. Now, this word, this sine theta, is the same thing as everything you have here, theta over 2. So, I can do substitution for theta. So, I have cos theta over 2 is sine 90 minus theta over 2. Why? Everything here is theta. So, since cos theta over 2 is the same thing as sine 90 minus 2 minus theta over 2, I can substitute this for this. So, it means the next line I can write sine 90 minus theta over 2 equals sine 60 degrees. Sine, they nullify. So, we are left with what? 90 minus theta over 2 equals 60. So what do? Let's multiply by 2 all through. So 2 times 90, 180. 2 times theta over 2, that's theta. 2 times 60, that's 120. Then we collect the like terms. 120 move here becomes minus. Theta move here becomes plus, positive. So you have theta equals 60. Therefore, we can say theta is 60. I would like to end the class like this. In my next video, we're going to take more examples. In this class today, I've been able to show the use of these two equations with these two examples. But in my next video, I'm going to solve more examples on this same subject. But I like to leave you with these few words. For you to be a good student, you must be fast, you must be accurate, and you must be neat. So I always tell my students to be Fan. Be fast, be accurate, and be neat. God bless you.